Good morning, everybody.
Good morning.
First things first. Hello, my name is Zia, and I'm here with Kiel and Anga, going to present about momentum conservation in collision.
So what is momentum? Momentum is a vector quantity, meaning it has both magnitude and direction. So the formula of momentum is, well, does anyone know the formula of momentum? We know because you made a slide. So momentum is mass times velocity.
Now let's go to collision. A collision is an event where two or more objects comes into contact and exerts forces on each other for a short time, causing a change in their momentum. There are two main types of collision. Elastic collision, total kinetic energy is conserved. In elastic collision, some of the kinetic energy is lost. Inertia. Inertia is the tendency of an object to resist any change in its state of motion. In simple terms, an object will stay at rest or keep moving at the same speed and direction unless acted on by an external force.
Okay. So who discovered momentum or physics, as we may ask, because we made the slide? It was I, Isaac Newton. I discovered physics and made their law. Made 3 laws.
Did Isaac Newton discover physics?
Yes.
So, Isaac Newton made 3 laws. So the first law of motion is state an object at rest will stay at rest until acted on by an unbalanced force. An object in motion will stay in motion at the same speed and in the same direction unless acted on by an unbalanced force.
Next, we have the second law of Newton. The second law of Newton states the acceleration of an object by a force inversely proportional to the mass of the object and directly proportional to the force. The formula for Newton's second law is force equals mass times acceleration.
Now I'm going to tell you about the third law of Newton. The third law of Newton states for every action there is an equal but opposite reaction. This law of Newton is the most directly connected to collisions. Why is it connected to collisions? So first, it's connected because when two objects collide, each exerts a force on the other. And then these forces are equal in magnitude and opposite in direction. And also because the force act over the same time, they cause equal and opposite change in momentum for the two objects. This is exactly why momentum is conserved in a collision.
Okay, so you must remember that I talked about the momentum formula. It's still there. So the measure of an object's resistance to change in its state of motion due to application of force. So we got the bowling ball, it hit cone, so it's still its resistance is strong enough to get back up. And if anyone forgot about the formula, we still wrote it.
So the examples of collision in real life is car accidents, billiard or pool balls, a bat hitting a baseball, space collisions like satellites or meteorites, people bumping into each other, waves colliding on water, and others.
Now, for our project, we also filmed an experiment In this experiment, we observed a car-toy collision and calculated the final velocity of the car using the law of conservation. The result shows that the momentum of the system before the collision was equal to the momentum after the collision, confirming that momentum is conserved in collisions with no extant force.
So the first step that we do, here we're going to calculate what is the mass of each car, then change the units into kilogram because the unit before is gram. The next one, we're going to then we're going to measure the distance of the toy cars before and after the collision, and don't forget to calculate the time taken. Then lastly, we're going to count or calculate the final velocity with the formula of perfectly inelastic collision.
Okay, so when a force is applied to an object, it will result in a change in momentum, which is impulse. As we can see, impulse is equal to momentum change. We have the formula right here. Triangle means change, if you do not understand.
Delta.
Yeah, delta. It also means change. So we have an example of impulse. So the momentum was instantly turned or changed.
Instance where Newton's first law of motion or the law of inertia comes into play, meaning an object stays at rest or keeps moving at the same speed and direction unless acted on by the external force. The example of Newton's second law of motion is when applied, pushing a shopping cart. An empty cart accelerates faster because it has less mass. A full cart needs more force to accelerate. Now, before we get to the end, we have one question as a mini quiz. Can you think of a scenario where Newton's third law of motion is relevant?
You guys know?
What was the third one?
The third one is
When a force gets applied to something, there's an opposite reaction.
the opposite reaction.
When I punch your face, you fall back.
Oh yeah, true.
Conservation of momentum. A scientific principle that states that the total momentum of a system or group of objects remains constant if no external forces act upon it. So first, this principle applies to objects in motion. It is closely related to Newton's third law of motion, which states that for every action there is an equal and opposite reaction.
Force is mass times velocity. So like something does the force. So these are types of force. We got contact, we got non-contact force. So we got magnetic force. Do you need contact for magnetic force? No, we do not, because they will. And then like gravitational force. Like try jumping. You will go back to Earth. It's called the gravitational force. Look, see it is gravitational force. And then we got the applied force or contact forces. The common one we can usually see is applied force, like look.
Yeah, like that. Then drag force, frictional force, and normal force. Force is a physical push or pull on an object that can change its motion on shape. So, in conclusion, the results of the experiment support the law of conservation of momentum. The total momentum before and after the collision remain
Approximately the same.
the same within experimental uncertainty. Small differences can be explained by factors such as friction, air resistance, or slide timing and measurement errors. This shows that momentum is conserved in both elastic and inelastic collisions, as predicted by Newton's laws. That's it from us.
Gracias.
Thank you for listening and pay attention.
Any question?
Attention.
Okay.
Sorry if there were wrong words or
Mistaken.
yeah. Thank
Okay.
you.
Give applause.